Okay, we have two numbers, that is 0.999 up to so on and 1. So are they equal? So to solve this problem, I will solve this problem in three different methods. So first method is, I want to take this 0.999 as x. So x equals to 0.999 and so on. Now I want to make a fraction so that I can cancel out them, and then I can show that x is equal to 1. That's why I want to multiply this x by such a number that will also leave the same digits after the decimal. Okay, so that's why I want to multiply this x by 10. So 10x is equal to what? That is 9.999 and so on. So 9.999, this 10x leaves the same part after the decimal. So now I want to give this as number 1 equation, and that is number 2 equation. If I subtract this 1 from this 2, I will have, that is 9x equals to 9, and then x equals to 1, right? And this is 0.999 and so on, that is equal to strictly 1, right? So this is my first method, that they are actually equal. Now I move to the my second method. So my second method is using series, infinite geometric series. So now my second method, since this second method is using series, so I will take this 0.999 as s. So s is 0.999 and so on. Now I can write this 0.999 and so on as this 0.9 plus 0.09 plus 0.009 plus okay 0.0009 plus and so on. Now if you see carefully that this expression, or this is a geometric series, and this is also an infinite geometric series, right? So s is a S is an infinite geometric series. So S is an infinite geometric series, and we know any geometric series has its first term. So our first term is represented by a, and a will be 0.9. So a is 0.9. Now since it's a geometric series, there is a common ratio. So my common ratio is represented by r, and that is equals to if I calculate this, then I will have 0.1. 0.1 is the common ratio, and this r, that is 0.1, that is strictly less than 1. Why should I take this less than 1 here? Because I want to calculate the summation of this geometric series. So for any geometric series whose common ratio is less than 1, that has a summation. So the summation is s infinite is calculated by a divided by 1 minus r. Now I just want to put this values of a and r here. So a is nothing but 0.9, and 1 minus r is 0.1. So 0.9 divided by 1 minus 0.1, that is also 0.9, and that is 1. So s infinite is 0.1, then s infinite is strictly equal to 1. So s infinite is s s infinite is just 0.99 and so on. So 0.999 and so on, that is equal to 1. So by the second method, or using the geometric series, I have shown that to 0.999 and so on, that is equal to 1. Now I want to uh, use limit here. So limit, because I have seen that it's 0.999. So here there are many nines here. Then I thought that 0.9 and 1, they can be written as, this is nothing but 1 minus 0.1, and this 0.1 can be written as 1 by 10, right? So number of 9, the number of 9 is the number of 10 here. Okay, this is my thinking here. So now I want to erase this first, and then I will move to my third method. Okay, this is my third method. So third method is using limit. So if I take this 0.999 and so on as x, and since I want to take limit here, so what did we what we did in our past, that is we solved many problems using limit. There was x tends to 0, maybe x tends to 0, or maybe x tends to infinite, or x tends to some finite value. And in this position we had some terms that was in terms of x, right? So I just thought, if I take here 9 and say that is, in this number there are n number of nines here. This number contains n number of nines. Okay, so that's why I can take this number as xn. So xn is this, and this part after the decimal point I have n numbers of n. So I want to make this xn 0.999 and so on. That's why if I take n tends to infinite, so if I take n tends to infinite, then the limit x n tends to infinite, where xn, then this value is equal to 0.999 and so on, right? If I take n which approaches to infinite, then this number is just equal to my question number first. So to solve this problem, I want to show you some experiment here. That is, 0.9 can be written as 1 minus 0.1, and that is 1 minus 1 by 10. So 0.99 can be written as 1 minus 0.01, and 0.01 can be written as 1 by 100, right? 0.01, that is 1 by 100, but I want to take here 2. So if I move to the next, so 0.999, that can be written as 1 minus 1 by 1000, but I will write this 1000 as 10 to the 3, because I have seen there are three 9 here, and I have the power that is 3. So if I take the number 0.999 and also 9, and in this part there are n number of 9, then this number can be written as 1 minus 1 by 10 to the power n, right? N is the number of 9s, then this number can be written as in this format. So our xn is just 1 minus 1 by 10 to the power n. So our problem, so now problem is solved, and this problem will be solved within 30 seconds. So limit n tends to infinite, and xn is 1 minus 1 by 10 to the power n. So just put the values of n, that is 1 minus 1 by 10 to the power infinite, and that is 1 minus 1 by infinite. So 1 minus 1 by infinite, 1 by infinite is just 0, and that is equal to 1. So xn, when n tends to infinite, that is the value we want to calculate, that is equal to 1. So I have shown you that 3 different methods that show these two numbers are just equal to 1. So that's it. Thank you.